While the rest of the world is still focused on trillion-dollar high-speed rail projects, tunnels through mountains, and transportation corridors beneath the sea, the United States has quietly chosen a different path that does not rely on the ground at all. Thanks to the rapid rise of eVTOL technology, short for electric vertical takeoff and landing aircraft, and entry prices starting at around $100,000, we are no longer talking about recreational flying machines. We are talking about a complete reimagining of urban mobility. This is a race for control of low-altitude airspace, where American engineers are establishing technical standards that every major power may eventually be forced to follow. I'm James, and these are the 10 flying vehicles redefining America's technological leadership on the global stage. Number 10. Alef Model A. The Alef Model A represents one of the most ambitious attempts to seamlessly combine existing road infrastructure with three-dimensional transportation. For decades, the biggest challenge facing flying cars has been their size and complexity. Most designs are simply too bulky to function as practical everyday vehicles. Alef's solution is a lightweight carbon fiber mesh body that encloses 8 electric propellers, allowing the vehicle to take off vertically from a standard parking space without requiring a runway. This design introduces a new engineering challenge. During high-speed flight, the vehicle rotates approximately 90 degrees, transforming its body into a wing-like structure. That creates complex aerodynamic stability issues that must be managed in real time. To solve this problem, Alef developed an intelligent gimbal cabin system that keeps passengers level and comfortable regardless of the vehicle's orientation. More than 3,500 pre-orders since its unveiling, the Model A has become one of the strongest indicators yet that the flying car concept may finally be moving toward commercial reality. Number 9. Rise Recon. While many flying vehicle manufacturers focus on luxury buyers, the Rise Recon is targeting something much larger: mass adoption. With a starting price slightly above $100,000, it aims to make personal flight accessible to a far broader audience. The key to that strategy lies in its classification under the FAA's Part 103 regulations, which allows certain ultralight aircraft to be operated without a traditional pilot's license. That raises an obvious question: how do you keep inexperienced operators safe? Rise addresses this challenge through a deeply integrated fly-by-wire control system that automatically limits altitude, speed, and flight behavior to reduce operational risks. Even so, one major obstacle remains. The aircraft's current flight endurance of approximately 25 minutes highlights the limitations of today's battery technology. Expanding that range will likely require the next generation of high-density energy storage systems, including advanced lithium, sulfur batteries, and other emerging technologies. The future of personal flight may depend less on aerodynamics and more on whoever solves the battery challenge first. Coming in at number 8, Pivotal Helix. Weighing just 355 pounds, the Helix uses a tandem wing configuration to generate additional lift without significantly increasing its overall footprint. One of the biggest engineering challenges facing lightweight eVTOL aircraft is maintaining stability in the turbulent wind conditions often found in urban environments. Helix tackles this problem with a distributed propulsion system featuring 8 independent electric motors, continuously adjusting torque in real time. The aircraft can compensate for sudden gusts and maintain stable flight. Its price tag, only $190,000, which includes a professional simulator training program, reflects a deliberate strategy to build an early adopt community. An important question remains: will residential skyport infrastructure be built quickly enough to support the growing number of ultralight flying vehicles expected to enter the market? That is a challenge policymakers and city planners have yet to fully answer. At number 7, Lift Hexa. If there is one aircraft on this list built around safety above all else, it is the Lift Hexa. One of the greatest concerns in personal aviation has always been engine failure. Hexa addresses that challenge with an architecture built around 18 independent electric motors. Even if as many as 6 motors fail, the onboard flight computer can redistribute thrust across the remaining units and maintain a controlled landing. That level of redundancy requires enormous real-time processing power and highly sophisticated flight control software. The next challenge lies in noise management and electromagnetic interference as these aircraft begin operating at larger scales. Today, Hexa is being tested for disaster response operations, where its integrated flotation system allows it to take off and land on water. In emergency situations, that capability could prove invaluable. Closing out the first half of the countdown at number 6, Beta Alia. Often described as a flying truck, the Beta Alia is already influencing how organizations such as the Pentagon and major logistics companies think about transportation. Unlike personal flying vehicles, Alia was designed for serious utility. It can carry up to 1,400 pounds of cargo or transport 6 passengers over distances approaching 250 miles. Beta's engineering philosophy centers around simplicity. Rather than relying on highly complex tilt-rotor systems, the aircraft uses dedicated lift propellers, combined with a separate rear-mounted pusher propeller for forward flight. This approach reduces mechanical complexity while increasing reliability. Biggest challenge now is charging infrastructure. Beta has responded by building its own nationwide charging network for electric aircraft across the United States. The company is betting that whoever controls the energy infrastructure will ultimately control the future of low-altitude aviation. Moving to number 5, Electra EL9. The Electra EL9 offers one of the most practical solutions, yet to the range limitations facing electric aviation. While fully electric aircraft continue to struggle with battery energy density, the EL9 employs a hybrid electric system. Compact turbine generator continuously recharges the batteries while supplying power to electric motors mounted along the wings. The result is a flight range of up to 500 miles, roughly 4 times greater than many fully electric competitors. Even more impressive is its STOL capability, short for short takeoff and landing. The aircraft requires as little as 148 feet of operating space, allowing it to use parking lots, rooftop facilities, and other compact locations that traditional aircraft could never access. Challenge remains in managing emissions from the hybrid power plant. However, with fuel consumption reduced by as much as 70% compared to conventional aircraft, many experts see this as a significant step toward practical regional air mobility. Number 4, Kytrafan 600. Top speed of approximately 300 miles per hour. The Trifan 600 blurs the line between an urban flying vehicle and a personal business jet. Its most demanding technical challenge is the transition between vertical takeoff and conventional forward flight. XTI addresses this with a system built around 3 ducted fans, including 2 wing-mounted units capable of rotating 90 degrees. During transition, the aircraft's flight control system must coordinate hundreds of adjustments every second to prevent a sudden loss of lift or instability. Trifan 600 demonstrates just how far eVTOL technology has progressed. It also introduces an entirely new challenge. How do air traffic authorities safely integrate hundreds or even thousands of high-speed flying vehicles into airspace that was originally designed for conventional aircraft? The answer to that question may determine how quickly the flying car revolution becomes reality. At number 3, Wisk Gen 6. Backed by the financial strength and decades of aerospace expertise of Boeing, Wisk has chosen one of the most ambitious paths in the entire industry: full autonomy. The company's vision is simple but revolutionary: remove the pilot entirely. Doing so not only reduces weight and operating costs, but also addresses one of aviation's most persistent challenges, human error, which has historically contributed to the majority of aviation accidents. Wisk's solution combines multiple layers of sensors with advanced artificial intelligence, capable of continuously monitoring the environment and automatically avoiding potential collisions. Yet the greatest challenge facing Wisk may not be technological at all. It is trust. Will passengers feel comfortable stepping into an aircraft with no pilot sitting in front of them? That question may prove more difficult than any engineering problem. To answer it, Wisk has accumulated thousands of hours of testing designed to demonstrate the safety and reliability of autonomous flight. Coming in at number 2, Archer Midnight. Archer has moved beyond prototypes and into the world of commercial aviation partnerships. Its flagship aircraft, the Midnight, is already supported by commercial agreements worth billions of dollars, including partnerships with United Airlines. Rather than focusing on long-distance travel, Archer optimized Midnight for urban routes between approximately 19 and 50 miles, the distances that dominate daily transportation in and around major cities. Its design incorporates 12 tilt-rotor propellers, creating a remarkably smooth and quiet flight experience. According to Archer, the aircraft type's profile is dramatically lower than that of a conventional helicopter, making it far more suitable for operation in densely populated urban areas. The next challenge is manufacturing at scale. To meet expected demand, Archer is building production facilities in Georgia capable of producing hundreds of aircraft annually. This is no longer just a competition of engineering. It is a competition of supply chains, automation, and industrial capacity. And that is an area where American aerospace manufacturers continue to hold significant advantages. Finally, at number 1, Joby S4, the undisputed king of urban air mobility. Joby is not simply building an aircraft. It is building what many industry experts believe could become the global standard for commercial air taxi operations. Through strategic partnerships with Toyota in manufacturing and Delta Airlines in commercial deployment, Joby has assembled one of the strongest ecosystems in the industry. The Joby S4 can reach speeds of approximately 200 miles per hour while maintaining an exceptionally low acoustic signature. Its engineering advantage comes from years of refinement, optimizing everything from electric motor efficiency to aerodynamic performance in pursuit of maximum range, reliability, and passenger comfort. Importantly, Joby became the first company in the sector to complete Stage 3 of the Federal Aviation Administration's type certification process, a milestone widely viewed as one of the most significant achievements in the history of the eVTOL industry. And that raises an intriguing question. Once commercial operations begin at scale, how will cities evolve when access to jobs, services, and opportunities is no longer constrained by traffic congestion and road networks? Perhaps the most important story is not any individual aircraft on this list. It is the larger picture they collectively reveal. The United States is not merely developing affordable flying vehicles. It is building an entire three-dimensional transportation ecosystem, integrating aircraft, autonomous software, energy infrastructure, manufacturing networks, and regulatory frameworks into a single vision of the future. The gap between America and many of its competitors is not limited to batteries, electric motors, or composite materials. It is increasingly defined by the ability to establish the safety standards, certification processes, and operational rules that the rest of the industry may ultimately follow. Flying cars are no longer a distant Hollywood fantasy. They are becoming a multi-trillion-dollar economic sector taking shape right now in factories, testing facilities, and research centers across California, Texas, and beyond. The era in which mobility was confined to the ground may be approaching its end, and in its place emerges a future where movement is no longer limited by roads, but defined by freedom in 3 dimensions.